Today we're looking at notes 5-9, solve quads using quadratic formula. So I've got the quadratic formula here, and this is our first example. So given this quadratic that's already in standard form, find the x-intercepts, or in other words, solve, okay, using the quadratic formula. So remember, the quadratic has to be in standard form, and it is, and then you want to list what a, b, and c are. So in this case, a is 1, the number in front here, b is 3, and c is 8. So then we're going to go ahead and plug into the quadratic formula. Okay, so I would have x equals opposite of b, so that would turn negative 3 plus or minus square root b squared minus 4 times a times c, all over 2 times a. Okay, so simplifying further, we have negative 3 plus or minus 3 squared is 9 minus, remember then 4 times 1 times 8. 4 times 1 is 4. 4 times 8 is 32. All over 2 times 1 is 2. So I'm going to kind of erase that, drew too much. Okay, simplify a little bit further. Negative 3 plus or minus square root of 9 minus 32 is negative 23, all over 2. So what's nice about this one is 23 is prime. There's nothing that divides into 23 other than 1 and itself. So that means my final answer for this is going to be x equals, the only thing I can do here, negative 3 plus or minus, is take out the negative, which would become I, square root of 23 all over 2. And there's nothing that can be done further here. Neither this nor this are divisible by 2. So that's your final answer. Okay, let's look at another example. So looking at example number 2. 2x squared plus 11 equals 4x. Okay, the problem with this quadratic is it's not in standard form. Okay, so I need to either move both of these two terms over to the right or just move this term over to the left. I'm going to choose to just move this one because I'd rather move 1 than move 2. So I'm moving this one to the left, but more specifically, since it's the x term, it needs to go in the middle. So this is going to be rewritten 2x squared minus 4x plus 11 equals 0. Okay, that turns to a negative 4x. So now a is 2, b is negative 4, and c is 11. So plugging into the quadratic formula, I would have x equals opposite of b, so positive 4, plus or minus, okay, square root of b squared minus 4ac all over 2 times a. So cleaning up a little, 4 plus or minus square root, negative 4 squared is 16, minus 4 times 2 is 8, 8 times 11 is 88, all over 2 times 2 is 4. Okay, next step, cleaning up a little bit more, 4 plus or minus 16 minus 88 is negative 72. So square root negative 72 all over 4. Okay, 72 obviously breaks up further. It's not prime. That number is even. So we're going to come off to the side over here, and we're going to break up negative 72. So obviously, first step, negative 1 times 72. 72 is 8 and 9. 8 is 4 and 2. 9 is 3 and 3. Okay, 4 is 2 and 2. Drag down this 2, drag down this 3, drag down this 3. So I've got a set of 2's and a set of 3's, and that negative 1 that need to come out. So then I would have x equals 4 plus or minus 2 times 3 is 6. That would produce an I, square root of 2 is left, all over 4. Okay, and then remember here, if possible, I can share the love. So I would share the love between these two, and I would share the love between this. So all three of these, you're looking at these three numbers, never looking inside the radical. That doesn't matter, can't break into the gel. The radical is a gel. Okay, all three of these numbers are even, they're all divisible by 2, and that's as far as you can go. So your final answer would be x equals, that divided by 2 would be 2, this divided by 2 would be 3, the I and the square root of 2 stay the same. Last but not least, 4 divided by 2 is 2. And I know it is so very tempting to cross out these 2's and say that that becomes 1. But remember, that would not be sharing the love with this guy. If you can't divide this by 2, then you can't divide this by 2. So you can't just cut across and forget to share the love with that guy. That would create a very unhappy problem. So leave it as is. As tempting as it is, leave it as it is. Okay, last example. I'm going to have to get a new sheet of paper, but I'm going to go ahead and start it on this one. So number 3. Number 3 would be 0 equals x squared minus 6x plus 13. Okay, this is in standard form. I know 0's on the left. It doesn't matter which side 0's on. This is in standard form. I've got everything on one side of the equal sign, so I can go ahead and get started. So first step, list A is 1, B is negative 6, and C is 13. So x equals opposite of B plus or minus square root B squared minus 4AC all over 2 times A, okay, which is going to simplify, of course. 6 plus or minus square root 36 minus 4 times 1 is 4. 4 times 13 is 52. So minus 52 all over 2. Okay, simplifies a little bit further. 6 plus or minus. If I have 36 minus 52, that's going to create a negative 16 all over 2. So hopefully at home you're screaming at me, 16, 16's a perfect square. The square root of 16 is 4, and you're right. So remember that this breaks up negative 1 and 16. 16 is 4 and 4, and technically since I have matches, I can stop. So the square root of negative 16 is 4i. Okay, so x equals 6. Maybe I can get away with not using a new sheet of paper. 6 plus or minus 4i over 2. What's really nice about this problem is I can share the love with both of these. All of these are divisible by 2. So on this one, I get 3 plus or minus 2i over 1, because 2 divided by 2 is 1, which really is just 3 plus or minus 2i. The 1 isn't necessary. So I'd like you to write out your final answer as x equals 3 plus or minus 2i. That's it. You're finished on that one. Everything simplified really nicely.